Hi, welcome to the video on group theory in chemistry, part 1. What is meant by group theory? Group theory is nothing but mathematical study of symmetry. And what is this symmetry? Symmetry is actually something related to proportion, perfect shape, size, and at last it is something related to beauty. And where does the idea of symmetry comes from? Actually, it comes from the mother nature, what we see around us. See this spider web. This spider web is almost spherical in shape, and they contain almost equal radius distances also. And consider the honeycomb. And the honey, we can see the perfect hexagonal rings are joined together to form the honeycomb. And scientists say that this is the best possible way in which the maximum amount of honey can be stored using the minimum amount of wax. And for us humans, if we want to draw such things, we have to use ruler and compass, and how these honeybees make these marvelous structures is a secret. And when we say about the symmetry, there are two types of symmetries. Basically, there are two types of symmetry: bilateral symmetry and the radial symmetry. Bilateral symmetry, the example of bilateral symmetry comes like this. Look at this fly and the dog. We can cut these two into two equal halves so that we can get two equal halves of it. And the second, the radial symmetry, something related to radius. Look at the starfish. We can divide it into 5 equal halves. And look at this flower also. Even human architecture is really taken ideas from the other nature and from the symmetry itself. Look at the Taj Mahal and the famous Lotus Temple in Delhi. The Taj Mahal, when we can cut the Taj Mahal into equal halves, they are symmetrical. The Lotus Temple is symmetrical. It contains the bilateral symmetry and the radial symmetry also. Also, our human body, we can cut into equal halves. We can say there is the bilateral symmetry in it. The coronavirus, it contains a bilateral symmetry and also radial symmetry. So we can say that it has a multi-dimensional symmetry in it. The famous Mercedes-Benz icon has symmetry, and the alphabets A with A, O, all contains this type of symmetries in it. A contains bilateral symmetry, O contains multi-dimensional symmetry. And why is group theory so much important in chemistry? Symmetry governs is because the symmetry governs bonding and hence the physical and spectroscopic properties in molecules. And also we can say the group theoretical principles have been exploited in chemistry in different areas that include atomic and molecular systems, electronic and vibrational spectra of all kinds, wide variety of thermodynamic systems, chemical reactions. It involves chemical combinational problems, stereochemical interactions at molecular level, potential energy surfaces, NMR spectroscopy, computational chemistry, and it goes on. And from the earlier definition, we know that it is the mathematical study of symmetry. It's called a group theory, and we have to take two important aspects. That is, one is the symmetry element, and the other is the symmetry operation. And what is the symmetry element, and what is the symmetry operation? Symmetry element is a geometrical entity, such as a point. It can be a point, a line like this, a line, or a plane about which a symmetry operation is performed. And what is a symmetry operation? The two are interrelated actually. A symmetry operation is a movement such as inversion about a point. We take a point here, we invert, this side become this side, this side become this side. That is called the inversion. And the rotation about a line, this is the rotation. And the reflection about a plane, this object can be reflected into two equal halves and so on in order to get an equivalent orientation. So we got the idea of symmetry element, we got the idea of symmetry operation, what is symmetry element, what is symmetry operation, and lastly we have to take equivalent orientation. What is an equivalent orientation? Equivalent orientation is an orientation similar to the original orientation, but not the identical. So we can see an example, H2O. The second figure indicates an equivalent orientation, and the third figure indicates an identity. Identity means the original image itself. So we will take an example, H2 as an example. Here H1O H2 is there, and if we when we rotate 180 degree, we get H1 as H2 and H2 as H1, and this is the equivalent orientation. And if we are not marking 1 and 2, we cannot indistinguish between these two, and the structure is called that equivalent orientation. And symmetry element and symmetry operations, we can have 5 types of it. And we have the symmetry element, identity, rotation, axis of symmetry, plane of symmetry, improper axis of symmetry, and inversion, center of inversion. And for each equivalent symmetry element, there is a symmetry operation and symbol for it. We can see that E, C, N, sigma, Sn, and I. Here we are taking only about the molecule symmetry of the group theory in molecular systems. There are other systems also, the crystal systems, and in molecules, we take the symbols E, C, N, sigma, Sn, and I. In symmetry, crystal systems in symmetry, it is different. The symbols in molecular levels are called Schoenfly symbol, and the symbols in crystal systems are called Hermann-Morgan symbol. Here we already discussed about the molecular systems. The symmetry element identity. Here we change the operation, leaves the molecules unchanged. Rotation axis of symmetry, it's a rotation and an angle 360 degree represented by Cn. Plane of symmetry, reflection in a plane sigma. Improper axis of symmetry, that is the combination of rotation and reflection represented by Sn. Inversion center of symmetry, inversion through in a molecule through an inversion center, that's I. And when we combine this E, C, and S, and whatever it may be, the symmetry operations, we get something called point groups, which we are going to discuss in the next video. Thank you.